two solutions.
But also, these were the things that I saw that I really remember, actually, from chemistry, along with my chemistry teacher, and really first got me interested in chemistry. So.
There's two solutions. It must be a quadratic
First one
formula.
is a solution of KiO3 potassium iodate. This is starch. That's why it's cloudy. It really doesn't dissolve. What's called sodium metabisulfite and a little bit of sulfuric acid. Okay, now watch.
Film the whole thing so I can see the stuff. That
and tell me if you see anything happen.
Oh man.
it's gonna blow.
Keep watching. Don't blink.
Whoa! Whoa! No!
How did that happen?
Oh my God!
Are you kidding?
Instant replay.
I got it on
Instant
camera.
replay. Instant replay.
Do it again!
That was really cool.
Make it turn purple.
That was like a...
Look at the rain outside. Oh my God.
Alright. That is one example of what's called clock reactions. And the color change at the end simply is iodine and starch. So if you remember from bio, you get that blue-black color.
This music is kind of scary.
He's kind of kicking me out.
It's a scopula. It's a scopula. Uh-oh, it's gonna
Okay, so now I'm adding some of this.
Whoa! Whoa! No way.
Well, that was
science.
That was actually good. These are
How does
very
that happen?
sensitive solutions. So sometimes it takes a lot of material. And now I'm going to add some of the potassium iodate.
Wow. That's so cool.
It's gonna blow up.
It's a series of competing reactions, very complicated chemistry, which is why on the one hand it seems to take a lot of time, but when it happens it's instant.
That's
Instantaneous. Instantaneous, right.
There you go.
So there are a lot of different clock reactions, and you could sort of adjust the clock, meaning the timing, based on things like concentration and temperature, so we'll learn about it.
Ooh, oh, ooh.
Pretty cool.
Okay, and I'm just going to, play a little bit because we got to get going on the other stuff.
What other?
Well, I got 8 more things to show.
Yeah, you broke it.
Ooh.
You broke it.
Okay.
If you get it just right, and the solutions are kind of touchy, they don't keep very well. You're going to keep them fresh pretty much. But if you get it just right,
I told him to turn it purple, and he turned it purple.
change it back and forth. But it's very complicated chemistry.
The whole thing in there.
Okay, so there's that. That's called the iodine clock.
The music.
Yep. Okay, that's the first one. Now, the second
chalk
one.
in there.
Whoa! Magic.
Match the music.
Okay, but it changes back. Okay, now. But this is something you have to make up fresh because by the end of the day it's just done, so hopefully it'll last through G block. Okay, so again, I saw these in high school. Oh, this stuff is interesting. Alright, so that's that. I see what your color. So what I'm going to do, there's its true color, it's purple. That's because of the manganese in the ion. Anyway, so I'm going to take some of this and I'm going to grind it. Why would you grind a solid? Surface. If you can increase the surface area by crushing, grinding, whatever, it'll react better. So this is called a mortar and pestle. This is the mortar, that's the pestle. Okay? And all I'm doing is just kind of push down, to smash it, and roll it around, and it'll crush it and make a fine powder. Okay? All right, now, the formula, again, is KMN. It's literally a source of oxygen around materials with formulas like glycerin, which has the formula C3H8O3, because this material has a lot of energy stored in it.
That's fine.
So what I'm going to do is... What?
Yeah.
What I'm going to do is I'm going to introduce some of this to that and then stand back and flip this on.
Whoa.
And hopefully this will...
What'd you say?
This will work. It takes a few seconds to get started, but you'll know when I'm playing fast.
Oh man.
Steam.
On the move, guys.
Fire.
That's hot.
Notice that, did you notice the color of the flame?
It was purple.
Like a lavender, that's the characteristic color of a compound with potassium ions in it.
Would that be safe to breathe?
No.
Yes. Open it up.
Okay, so we use the term exothermic, very exothermic reaction. A lot of energy.
Where is this air going?
Up and down.
The air vents.
Wait, I'm so even above the air vents.
Yeah.
If we're not supposed to breathe that, then why is it cold?
There's a fan. It's pulling the air up. Notice the way the smoke is gone? So as long as that switch is on, it'll be fine. Okay, so we'll be back here for something else later. I'm just going to leave that on. It's going to be very smelly.
Oh, great.
So watch what happens. It's going to smell.
Good.
What do you think what did I say the name of that second stuff was?
Ammonia. It's gonna
Ammonium
smell like that
thiol.
stuff
It's going to smell like ammonia, exactly. That's one of the things producing the reaction. But look at what else is happening.
It's like bleach.
It's forming water, which once you get a solution going, now the stuff can react really well. So this will react pretty well now, releasing water, making a solution, which makes it even easier, forming ammonia, which is very smelly, but hopefully there's something else that'll happen.
Clean some glass now.
Don't know yet, but let's keep going and see. There we go. Wow. What did it do? Feel the beaker. Feel the beaker.
It's freezing.
Right, it's a very endothermic reaction. It takes a lot of energy. So it takes the energy right from the water on the sponge. So it literally froze to the sponge. Wet sponge froze to the sponge.
Can you take this off?
It didn't. It took the energy from the water on the sponge in contact with the glass. In other words, the energy of the water went right through the glass into here, making the water cold enough to turn to ice, so it froze it to the sponge. Okay, so very endothermic reaction. Just like the potassium permanganate. So what I'm going to do is put a bunch of this stuff in, a little bit of chunky powder. So KClO3, again, percentage-wise, it's got a lot of oxygen. A lot of materials have a lot of oxygen stored in it. Now, things we're going to learn about, like types of bonding, ions. When ions bond together, the bonds are very strong, which means all ionic compounds are solids at room temperature, very high melting points, because the bonds are so strong. But we need to melt this first so that we have it ready to do what we want with it. And you'll see it's going to take a minute or two to melt this, even with the direct flame.
Yeah, if the zombies were coming after me, I would put you in front of me. No, I'd be like, put that right in front of me. Would you look at them?
Okay, so now I'm ready for this to react. So now I'm going to sacrifice a gummy bear.
Gummy.
Oh my god.
Yeah, this is gonna happen to you.
Oh my god, this is gonna have the world.
That's okay, it takes air on me.
That's gonna happen to you.
Caroline.
Notice the color of the flame, by the way.
No one likes the
There's
yellow
that
ones.
pink flame again because it's got potassium on it.
How do you clean these things
That
up?
there.
No one likes yellow.
No.
Yeah. Okay, now, a couple quick things. The interesting, guys, come on, really.
Hey.
The interesting thing is, all that energy that was released from a gummy bear, one gummy bear, that's the same amount of energy that's released when you eat it. Of course, it's not in the form of a flame, but you saw that energy. That's how much energy is stored in a single gummy bear.
Oh, I can't.
Fairly
I'm like
quickly,
leaning.
see something happen.
Eat away the copper after.
Well, it's not.
Oh, you're zinc plating it.
It's actually not taking away the copper, it's adding in zinc.
Yeah.
So these are going to be zinc coated. And the reason I said about, you know, if you have shiny pennies, it just looks better if they're shiny. But there's actually more to it than this.
Yeah, they think they're dimes.
Have to get them coated. You can see because the original penny was very shiny. This is pretty shiny.
Oh my God, that's definitely a dime.
Yeah, Abraham Lincoln's on a dime.
Yeah, I'm
Well,
actually
we're not gonna notice.
going to do a little bit more.
No way.
Yeah, this is right.
It looks like
Brass. How did you know that, Zach?
Guess.
Okay, now think of what I did. The pennies were copper. I coated them with zinc. Now I didn't melt the metals, but the heat is enough to soften the metals so that they mix.
Oh,
Ooh, that's so cool.
oh my God.
They look like Chuck E. Cheese tokens.
So
You could make your own.
the heat softens the metal enough that the copper and brass combine to make, the copper and zinc combine to make brass.
Oh, can I touch it? I want to touch it so much. Oh my God.
Okay.
Oh my God, I see the gas going down.
You see it going down?
I see the gas going down.
Oh my God, she sees it.
Okay, did you see that?
I didn't see it. Wait, do
All right, I'm going to do it
I saw
again.
the gas going down.
Okay, so
Sure.
I don't know. I can't see it.
what does that tell you? Deanna said, I see the gas going down. What does that tell you about? Right, exactly. The vapor that this liquid produces is denser than air. There's actually a real simple way to figure that out. I am pouring a gas. And what else can you say about the gas? It's flammable.
You see it going down? Oh my God.
What?
How do you not see
Everyone,
it?
she sees it going down. Oh my God, it's going down.
Oh.
So, couple quick things. You know how we're doing molar mass, right?
Yeah.
Real simple thing. Nitrogen, N2, about 28 grams per mole. O2, oxygen, about 32 grams per mole. If you average out air, it's roughly about 30. It's not a compound, but the average is about 30. Anything with a molar mass greater than 30 is more dense than air. That's it. So this has a formula, this is called hexane, has a formula C6H14, so its molar mass is about 86 grams per mole, more dense than air. And because it's carbon and hydrogen, it's very flammable. So all I need to do is vaporize this, which happens very easily. And when the vapors get to the bottom and hit the flame, I just don't want to pour any liquid because that gets a little messier.
No, it's
Am I
not.
near the liquid?
No.
Not even close.
Yeah, sometimes the vapor, oh, there we go. That was a little slow, but you got the idea, right? Little jars. And then I'm going to do a couple more things, and then I'll explain what you three guys have to do.
Famous.
Okay, so first you get that sort of brown stuff, and then it goes away.
It's nice and brown. Good color of that. Oh my God, I smell it.
I know, this is the strong ammonia.
So strong.
I don't smell nothing.
Yeah, I think it's the fans are
Oh,
not
I
blowing.
smell it.
Oh no, it smells like hair dye.
Breathe through your mouth. Breathe through your
So
mouth.
brown. Like so
Okay, so
Oh,
now I
looks
have
like
to-
coffee.
There it is.
It just hits you. It's like bam.
And then I'll be able to put the
Shut
cap
up.
Oh my God.
I honestly don't smell it at all.
That was really strong. Smells like bat.
Something like that.
I don't get it. Wait, you think Pat looks like a sloth?
I smell it so bad.
Wait.
It hurts your nose. It's like.
No. It's like a whip. I don't even know what a sloth looks like.
Alright, so once I put the caps on, then you guys take it and just do that, and then I'll get the last thing ready.
Looks like maple syrup now.
So Matt,
All right,
What do I do?
what
Just
we got here? Shake it.
just shake it back and forth. You want to keep the
do it so we can
keep
see
the
it.
inside coated.
I can't
Zach,
really see when I'm shaking it.
Okay, was it like
Mine
that
keeps
before?
dripping. No, dude.
So hold it on tighter.
It looks like
I am.
Okay, so what's happening?
It's a mirror.
Mirror coated it.
Yeah,
Right?
this is
Off
called
the sun.
the silver mirror reaction. This is how they used to make mirrors. So there's a coating of silver inside. So a couple of US, that's the tarnish, like if you have something silver and it turns brown. Okay, on the inside, you'll be able to take, I'm going to rinse them out, then you can take it. On the inside, it'll turn brown, but because this part, this silver is protected by the glass, this part won't turn, so it'll stay silver on the outside. In fact, open the two closets there on the left, and look at all the silver stuff from other years.
Down there.
Sodium chloride, the characteristic color, if I have salt, good, is of sodium is yellow. Like if I took a little salt, put it in a flame, it would glow yellow, just like that potassium stuff glows violet. So what I'm going to do is energize this, but I'm not going to use the flame. I'm going to use electricity.
Oh my god.
I'm gonna shock a pickle.
And you'll see why I do
do it
this
to a
last.
jalapeno?
Because it's really,
Can you do it to a jalapeno?
anything salty, yeah.
It's so cool.
Stab it.
Smell it.
Yeah, it's going to smell worse. That's why I do it last. Okay, ready?
Okay. I'm leaving. It's on fire.
Oh my.
More pickle!
What the hell are you doing with a pickle? Oh no.
So there's the characteristic yellow color of a sodium flame.
Oh my god.
This is
Smells
called
like a
Big
burning
Surprise.
fly.
The electric,
Burning pickle.
the
You ever
electric
burned a
pickle.
fly before?
Oh yeah. Oh yeah, they're fried pickles.
No, you wouldn't
It
want
looks like you never did that.
Okay, that's it. I don't want to leave this on too long.
You've never
really
eaten a
reeks.
shotgun
It smells
before?
good. I
Wow.
like it.
Yeah, I like
Oh,
Jimmy's.
that's not so nasty.
I like the smell of
I mean, you smell it.
I don't like pickles, but I
Okay,
think it's so good.
lights.